Khetz Tutorials, and this is where we left off in the previous video. In this video, we're now stepping away from loops and talking about some other things, basically. So, if, else, if, and else. Let's create a new file. Not quite sure what to call it. Naming things isn't the easiest thing in the world. Trust me. Let's call it if. That's not descriptive enough, but hey, what can we do? So if you call that f.py, then it creates a file. It doesn't discriminate, even though our name doesn't quite make sense. It actually does make sense because we are talking about if, else, if. So the elif is else, if, and else. Okay, so how do we wrap our heads around these things? What do they mean? So if you have a basic idea of what these things mean in English, then you are halfway there. I'll just give a basic example. Let's start with if. If it is sunny, let's say I am promising you something. I'm promising to take you out. If it is sunny. Now, if it is sunny, we will go to the beach, right? If it is not sunny, I will not, then I will not. But take note of the fact that we have a bunch of other conditions that are not. So if I say we will not go to the beach, I didn't specify why we would not go to the beach. The reason might be that it's windy, it's raining, or something else. Called conditionals, 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 called conditional statements, and they check for conditions. An if statement would check, and it would be the first check. Now the second check, if you want to check for another specific condition, would come to else if. But if we want to group all of the other conditions without even naming them, we just jump straight to else. So if it's sunny, I'll take you out to the beach. If it's not, then we won't go. So we won't go. But in between, if you want to actually specify all of the other conditions that would stop us from going to the beach, then you'd come to else if. But if you wanted to check for other conditions that would stop us from going to the beach, you'd say else if, then you'd specify those conditions before you come to else. So else is a default, or it is an alternative that covers all the other options apart from the initial one. So let's make this make some more sense in this way. Let's write it down in pseudocode. So pseudocode, we're just basically writing in English, and it will be converted to code at a later stage, something like that. So if it is sunny, let's write it as in basic terms. If it's sunny, then we'll go to the beach. If it's not sunny, so we have an else statement, it's not sunny, then we won't write won't. Let's just write won't. And these are the if and else pairs. This is not necessary, just that we want to cover if, else, if, and else, right? So if it's sunny, we'll go to the beach. If it's not, we won't go. But if we wanted to check for other things that we could do, we want the day to be eventful. We want to do something at least. So we shouldn't just depend on going to the beach or not going to the beach. So what would we do? We would basically then say that we want to look at some other options, right? So if it's sunny, we'll go to the beach. Else if it is windy, well, if it's windy, we don't want to go outside, we'll watch a movie indoors. So watch movie. If it is raining, we also don't want to go outside, so find another activity to do. Maybe we'll make a bonfire somewhere where we have shelter, right? Fire, I don't know what you'd want to do when it's raining. And some other conditions you can also basically specify going down. So you can have an unlimited number of else if statements which check for other conditions apart from the main one. So the main condition is checked for using if. So you can't start with else if, because when we're saying the word else, we are moving from an initial checkpoint. So the main one, you start with an if, then that you want condition that you want to check. So it would only come to this one if this one fails. So we're checking if the condition will fail or not. If it's not sunny, then something else, which means this will fail. It will check for this, if this, but if this one passes, then it will never get to all these other ones because it's sunny. And it will only execute the code that is inside that block, or which is indented in there. So it will keep checking. If that fails, go to that. If that fails, then we finally can have an else, which covers all other conditions which are not specified. And even if you don't have this else, it will just basically continue to any statement which is outside the if and else if stuff. So I hope this example kind of gives you an example of how you use if, else if, and else. I also have two examples that I want us to go through. So let's get to those examples. The first one, let's define a variable x. And I gave x the value 6. It's an integer, right? And we want to check, is x an even number? And just remember that an even number can be divided by 2, and you basically have equal halves with no fractional parts. So it's basically divisible by 2, and you have equal parts. And if it's odd, then you can't divide by 2 without having remainders or some weird things happening around. Okay, so my first question to you is, how do you check if a number is even or odd? Well, we mentioned that if it's even, it's divisible by 2. And if you go back to one of the videos where we talked about arithmetic operators, there is an operator called the Modulus Operator, which checks for remainders. So if we divide by 2, and the result of that is a number with no remainder, then we know that the number is even. So if we divide by 2 and there's no remainder, that number is even. If we divide by 2 and there's a remainder, then that number is odd. So that is the check that we're going to use to verify or to check whether x is even or not. So how would you write that in terms of code? We just learned of the if statement. So you're going to say if, then we're going to have a condition with the loops, and this condition checks x because that's the variable that we're interested in, and we're going to use the modulus operator to check for the remainder after dividing by 2. So remember, the modulus operator basically divides with the number that you specify and puts the remainder of the divided. So this is like division, but instead of the answer of x divided by 2, it will produce the remainder after dividing by 2. So what do we want? We want the remainder to be 0, right? And remember that this is a conditional, or this is a comparison operator. We're checking for equality. So this statement will produce the remainder. And we want to check, is this remainder equal to 0? That is what that is for. And we're going to continue with our if statement. Then we're just going to print that it's even, because it passes this condition up here. So let's revise our condition. We're checking if x is even by checking if it has a remainder, right? How do you check if it has a remainder? We use the modulus operator. How do you check the remainder that comes out of there? We use this equality operator, and we compare it. If there's no remainder, this will be 0 and will be exactly equal to 0, which means it passes. Now that it passes the condition that is specified by the if statement, then it will execute the code that is indented in that if statement. So when the condition is true, it will now come inside the indented code, the code that is inside the if statement, and execute. But what is the other option? In this case, we only have 2 options, even or odd. So we don't have to actually check again and say else if, because we know that if it's not even, it's odd. Okay, so look at another example that might have some other options, and we'll get to that in a moment. Now with the else, you don't have to specify any condition because it's the only other alternative. Then you're just going to print odd. So if it's not even, it's odd, and we're done. So the first statement of the if statement says, if x modulus 2, which will bring out the remainder. If the remainder is 0, then print even. Else print odd. So x is 6. We know that 6 is an even number, so expect it to print even. So once it gets in the if statement, so if the if statement passes, it will only print that out. The else statement will fail, so it will not execute the stuff that's in the else statement. So if you have a bunch of if, else if, and else statements, and only one of them passes, or only one of those conditions is true, then the other ones will not be executed, even though they follow each other in sequence, right? So only one statement will be executed if the if and the else arguments are linked, or if they are on the same line of indentation. So it's taking quite some time, but we expect it to run in a moment. And this is just a simple example, even or odd. Okay, so there it is. 6 is indeed even. We can change the value of x to a number which is odd, like 111 or 11. We can leave it at 11. We know the 11 is indeed odd. You're going to run that, and hopefully it doesn't take that much time, and it is taking a lot of time. Let's be patient and wait for it to run. Expect the result to be odd. Okay, and there's the result. It's odd. So you can play around with this just to check for whether this is even or odd. And you could have started with the odd part of it. So when you start with, you can start by checking if it's odd or even. So you can swap these things around. And as an exercise for you, I want you to convert this into, so start with odd, then have the even in the else statement. So that would mean you have to change this condition so that this prints odd. So what I want you to do, I've already filled in this part for you. In here, it has to print odd. And in here, I want it to print even. So what you have to do right now is to change this condition so that it comes in here when this x is odd. So how would you change this statement so that you actually have a check for the number being odd or not? Okay, so that's an exercise for you that you can do by yourself. But now I'd want us to move to another example, which is more involved, if I can put it like that. And in this example, before we get into it, I just want to revise the grading system in South Africa. So other countries have A plus, B minus, and all those things. But we usually have levels from 1 to 7 in our schools, like grade school. And these come in the following ranges. So ranges are as follows, if I can, okay. So from 20 to about 29 point something, you'd get a level 1. So these are marks or percentages. And if you get a 30 to about 39, they're about 39 point something, it's a 2, level 2, and so on. So it goes up like this, and this will be a 3. Okay, so this is actually supposed to be 49. That'll be level 3. Then you have from 50 to 59 point something, then you'd have level 4, and you'd move up to 60 to 69 point something over there. There'll be level 5. I'm not quite sure why I took this up because I'm running out of space. Let me write on this side. And if you have 70 to about 79 point something, you'd have a level 6. And finally, 80 and above, so 80 to 100, you have a level 7. Right? So that would be a distinction, which is the range 80 to 100. So this is our grading system in South Africa. And what if we wanted to have a program which checked where a specific mark or percentage can be found? So we can start doing that. So let's call it score. I'm just going to have a single number just for simplicity. We can give it any value. Now, what we want to do is we want to check for all of those ranges. Remember, we started from 30 to 39, 30 to 39, and so on, building up. So it's always up to you which one you start with, right? You can start at the bottom or you can start at the top, but it's usually easier to start at the top so that your code falls through. So you start with the highest, then if that fails, Then if that fails, you check for the one that's below that, the one that's below that, or you can start with the smaller one and then increment or increase. And what I mean by that is you can start by checking if a value is between 80 and 100. If it's not, then you can check for 70 to 79. Then if it's not, you can check for 60 to 69 and so on. So this is what we're going to do, but in code. So we talked about if statements, and those are the ones that we're going to use. The main one, or the main one, and we're checking score. So you're going to say if, and then the variable or whatever it is that you're checking. So what is our condition? Should it be greater than 80? And the answer is no. It should be greater equals to 80, because remember that level 7 is 80 to 100. So 80 is included in that range. So look out for that, whether it's greater or whether it's greater equal to and stuff like that. So we just want to print. We don't want to do much. We want to print the level. So let's say print level 7. Okay. What other condition do we have? If it's not 80 to 100, what else can it be? So the next one is 70 to about 79. So if the score and file, like in mathematics, you'd have inequalities, or you'd have something like this. Actually, we can call it X. We'd have this in mathematics, X in between there, right? And we don't have to specify both sides. It's sufficient that we only have 80 greater equals this score greater equals 80. That is sufficient. It covers everything from 80 until we reach the end, which is 100. So we don't expect, we are assuming that this will never exceed 100. The person just does, that person just be given level 7. And we can do that as well with the second one. We can just do this, because the bottom one is 70. So if you start with the highest range, look at this. If you start with the highest range, which is 80 to 100, then you go to 70 to 79. Note that you only have to use the lower bound, or you only have to use the lower number to check for your conditions. So you never really touch these ones because they are implied. So once I say score greater equals 70, it is implied that I'm talking about all the values that are greater than 70. But remember that it will only come to this point if the first one has failed. So that would mean that we had 80 to 100 and it failed. So it didn't fall in there. So since it didn't fall in here, it will pass and it will come here. So it's actually from 70 to 79 because it has already failed this one and it's now only checking from 70 to 79. So this here check is equivalent to just checking from 70 to 79 because this check up here from 80 to 100 has already failed. It will only check the next else if statement if the previous one has failed, right? So if you had a 71 there, it will fail the first one and it will check the second condition, and that is when you'd print that you have a level 6. And if it fails this one, it will now go to the next one. So I'm sure you now have the hang of it, and you can now just take the lower bound or the lower value of each of those ranges that I mentioned. And so I'm just going to fill this in quickly, and we're going to talk about everything that happens at a later stage. But what I'm basically saying is it will not go to the next if statement if it hasn't failed the previous one. So if it fails that one, so if the number is not between there and there, then that is when it will come here. But if it falls in there, it will never evaluate or never check these values. So it just stop there, right? And that is how it falls through. So you can look at this as something that falls through when it fails. So if the condition is not true for that number, that is when it will proceed to the next one. So it will proceed to this. If it fails all of the ones that I've basically mentioned up there at the top, we'll move on to the next one. All right, if score. Okay, so basically done filling in our conditions. We're basically checking for all of those ranges, but just using the lower bound or the lower value that is found in each of those, and it suffices or it's enough because we've already checked the ranges that are above it. As I said, it will only check the if statement if the one before it has failed, right? So now let's change this back to 80. We expect a level 7 as the result, or as the output. We expect it to print level 7. So you can play around with this on your own. And as an exercise, you can swap this around and start with this one, then go to this one, and so on. So basically start with 20 at the top, then have 80 down here, or whatever number that you'd have. What I'm basically saying is we are now starting with the highest range, and we're moving down to the lowest one. And I want you to swap these things around. I want you to start with the lowest range, 20 to 29, and end with the highest one down here at the bottom. And here's a hint: you won't have these values. You won't have 80, 70, 60, and 20. They'll change to something else, and that is for you to figure out. And I can just tell you at this point because I feel like telling you. So when you start with the highest one, you are going to take the lower bound. So the range itself is 80 to 100. And since we're starting with the highest one going to the lowest, we took the lower bound. If you start with the lowest going to the highest, you're going to take the upper bound, and you're going to use the opposite sign, which is less equal to. So you'd now say score less equal to 29, which means it's 20. Then you check for the bigger ones using a similar approach, but now using the upper bound and the less equal to. So this would come up if you wanted to start with the lowest one, and the 80 would now go down there, and 100 become 100, but now using the less equal to operator. So if you swap those things, if you start with the lowest range, 20 to 29, then that is how you'd change this code. So it's always easier to follow if you start with the highest range, because we start at the top and we fall down to all the ones that are lower than that. And it makes more sense this way, at least to me. But you're totally free to change this around. Just make sure that the flow of your if statements makes sense, right? So you can't check for a condition, then say else if, and you have another condition which is not related to your previous condition. Your code might work or it might run, but your logic might be wrong. So make sure whenever you use if, else if, and else statements that your logic is correct. Let's just run this because we have been talking and we haven't ran even one. So I should probably just finish the installation before I do anything else. But let's just finish this video by trying another number. So let's say 19. That's a very low score, and where do we expect it to fall? It is not even part of these. So that's a good example. So it didn't print anything because it's not even part of those, right? If it's less than 20, so this starts from 20 to 29. So we can also add something. We can add an else. So if it's below 20, which is not part of these numbers, we can call it level 0 if you want. I've never seen it, but we can just define that ourselves. So that's what expect to happen. So if it doesn't fit these ranges, that's when the else comes in. And as I mentioned, the else covers all other things that are not specified. So everything else which is not part of each of these ranges that we talked about will fall under the else statement. That is why we have level 0 over there, because score is currently set to 19, which is not part of the levels 1 to 7. So play around with this, change it up, try to think of scenarios that would require if statements, work on a problem if you do have one, and that is how you basically work with if, else if, and else. I hope this made sense. I hope you liked the video. If you do like the video, just give it a thumbs up. If you haven't subscribed, please consider subscribing, and I'll see you in the next video.